Hello, and welcome to the introduction of object-oriented programming. At this point in the course, you should now have gotten a nice introduction to Python, and you should also have gotten a nice introduction or hopefully build upon your understanding of building functions and calling functions and passing data appropriately. We started that in Programming 1, and hopefully we built upon that a little bit in the last couple weeks of this course. Now we're going to dive into truly what this course was really meant to be. And this course was really meant to be to teach you object-oriented. Yeah, we're going to use Python as the language, but for the most part, we don't really care what language we're talking about. We're talking about the concept of object-oriented. So for the remainder of this semester, everything we're going to be doing is really around understanding the concepts and applying the concepts to developing an object-oriented program. All right? This particular video will kind of get us started. I just wanted to take a breather here and allow you some time to try to get your hands around, or try to at least begin to get your hands around the whole concept of what object-oriented is, and try to eliminate some of the fear that people seem to have when we bring up this term. All right, so what we're going to do in this particular video is talk about what is object-oriented, why are we learning it, what is the benefits, how does it work, and the 3 tiers. There'll be subsequent videos that will talk about some of the terminology that you hear when we talk about object-oriented, and also a video that will walk through our process that we're going to walk through the remainder of this semester to help you learn this and how you should attack it, if you will. Okay? So make sure you listen to all these videos so you can get a nice introduction to this. I think it's going to help immensely. All right, let's get started. So what is object-oriented? Object-oriented is simply a programming methodology. That's truly what it is. It's a way of doing something. All right. This development began in the 60s, probably even the 50s, and really caught on and is now a staple in the development arena to this day. It's been around for many years, 50, 60, 70 years. It has actually been around and being used. I always tell students there's 2 things I have seen throughout my career that has stuck, because we've always tried to figure out better ways of doing things, but there's 2 things that have always stuck: relational databases and object-oriented. So you should already know a little bit about relational databases. Now we'll get into object-oriented. Again, it's a methodology. It's a way of doing something. Programmers always notoriously try to figure out a better way of doing something. If we sit back and look at this little chart here, which I took from the internet, I think it's a really good one to sit back and give you an idea what we're talking about. Back in the 60s, we basically dealt with machine language. Programmers wrote everything in machine language, hexadecimal code. All right, wasn't very structured, wasn't very easy to maintain, wasn't anything. So businesses now started incorporating computers more and more in their business. Well, part of doing all of that was being able to write software and also maintain software. Trying to maintain machine language is never easy. With that, new languages started popping up. Assembler language, which got a generation away from machine language, okay, which made things a little bit easier to understand, yet still wasn't too English-like and still pretty hard to maintain. We finally started getting into structured programming languages such as COBOL, Fortran, and so on. And then we actually started diving into procedural programming languages like Visual Basic, C#, some of the things you guys should actually have been playing with and you'll see today, including Java, and so on and so on. All this worked well. As a matter of fact, I developed many of these types of things in business, all the way back to assembler, all the way through to procedural languages. However, in my career, back in the late 70s and early 80s, I guess we should say, I'm going to say late, I'm going to say that differently. Early 80s to late 80s, I don't want to age myself too terribly bad here, even though I just did, we basically sit back and we got into object-oriented, all right? And so again, why did we change all of this? Why was it important to change around? Businesses, remember what you're developing to do. Let me stop for 1 second. What you're trying to become as a developer is to be able to go out to a business and become an application programmer that can leverage technology to improve that business. That's what I did. That's what a lot of people who are going to become software developers do. There's other courses you can go or other paths you can take, but for the most of you, that's pretty much what you're going to be doing. The whole idea, though, is that businesses wanted to develop software as quickly and as cheaply, but as correctly as possible. So once again, we always try to find better ways of doing that, and that's where object-oriented come into play. Why are we doing it? I'm just repeating what I said a second ago. It's used heavily in industry today because it is a method to ensure that we can maximize everybody's time and everybody's code that's already been written. Also, many languages use it today. You'll start recognizing that many languages are also object-oriented programming languages, such as Java, C++, VB, C Sharp, etc. Visual Basic, what you just got done doing, was object-oriented programming language. What is the benefits? As I just kind of said before, the benefits was always trying to find a better way to develop software. Their goal was to develop software more quickly with less errors. Again, business is one of the things up and going. They didn't want to spend years trying to get something developed. They had a need. It's going now. Object-oriented allows itself. How to do that? Well, basically it does it because it allows for maximum use of existing code. And also maximum flexibility in using that existing code. What does that mean? Well, basically what that means is that if I'm in a programming shop with 400 people, that's what I started with at AT&T. We had 400 different programmers in our group. If I write a piece of software and maybe a fraction of that software could be reused in a program that, Billy Bob is using down the aisles or so on, instead of him rewriting that software, we put this software in a location where he could find that and reuse it. That's what object-oriented is all about. For an individual programmer like yourself, that's hard to really conceptually understand. I get that. That's why this is not an easy course to teach. But for the most part, that's what it's all about, is reuse, maximum reuse. And not only just reuse, maximum flexibility. You'll start seeing, instead of just copying it over a function and using it, or when we'll get an object-oriented, we can not only use it, but we can make it a little bit more to our needs, develop it to our needs, if you will. And you'll see how that works as we continue on throughout this semester. So what does this all mean? Well, usually what this means is that we have this thing called class libraries. All right. So this object-oriented stuff is we develop this thing called a class. We'll talk a little bit more in detail in the next video about what a class is. But a class is basically a program. And we put all these little programs out in a library. It's called a class library. And basically they're all different shapes and sizes, and it's all based upon the overall design. That's what OOD stands for, object-oriented design. Okay? So our analysts will come together to try to tell us how to develop these classes. Usually these classes are all based upon the business in which we're working for. And again, we'll talk about that more as we get into the course over the next several weeks. But that's really pretty much what we're doing. We're developing these things and putting them out in the library. The application programmer then will write his applications by using one or more, maybe several, different classes and maybe different things in the class to make his program work the way it's supposed to work based upon the requirements. So all business logic, if you will, meaning all the if-then conditions and so on, resides in this. And again, it's sitting here for not only this application programmer to use, but many application programmers to use. If the application programmer decides that he needs new logic that's not out here, instead of him writing it by himself, he would develop a class for it so others can then use it. Does that make sense? Go back and listen to what I just said again if not, okay? In the end, my application programmer, for the most part, deals with the interface, meaning how the interface looks to the end user, the input validation, and the output display. So for the most part, but all the logic, all the processing logic, from taking your inputs to making them outputs, all resides in one or more classes. Does that make any sense at all? Once again, this is just an introduction. I'm not asking you to memorize this. I'm trying to get you to get your head around it a little bit. All right. You'll also recognize that there'll be this terminology out there. What's all these classes made up of, all object-oriented? Well, we have three different levels, three different tiers, if you will. There's the presentation tier, which is the interface. There's the business tier, which is the logic, and there's the database calls, which is the data tier. The interface is basically what you've already worked on in programming 1, which is dragging and dropping buttons and controls and so on in a form. All those controls were basically in a class. You may not have known that, or maybe you've seen little tidbits of it, but it was something that was already developed for you that you didn't have to develop yourself. Back again when I started, we had to develop every one of those. I couldn't just drag a button on the form. I actually had to program it using bits and bytes and hexadecimal code. That was not fun, but I did. Today, you drag it out there. So somebody wrote the code for you with those bits and bytes and hexadecimal code so you can reuse it over and over again. So you've actually dealt with that a little bit in Programming 1. Database is a data tier. We can actually write classes that we'll call the database. We'll talk about that a little bit more in subsequent classes, but for the most part, that's what we're doing, okay? And finally, the logic, okay? The actual logic, I call that business logic, meaning the sequential, the conditional, and so on, that doesn't really deal with validation, all the processing, all the questions we ask, and so on that you've already gotten into, all right? That business logic actually resides in the classes, and that's what we're going to focus on in this course, creating classes that deal with the business logic. All right? With that said, that's the conclusion of this particular video. And so what I want you to do is maybe listen to it one more time if you need to, and once you're finished, move on to the next video that will talk about some terminology.